Hey guys, Mrs. Thompson here, and today we're going to learn limiting and excess reactants. This involves stoichiometry, so if you haven't learned that, you need to go back and watch a video on that. In limiting and excess reactants, what we've been looking at before in the past when dealing with stoichiometry is we said it reacts with an excess of oxygen or an excess of hydrogen, and that was so that we only had to deal with one given. Now we're going to have problems where we aren't given an excess of one reactant. And so what we have to do is we have to do a little more stoichiometry to figure out these problems. Okay, quick definition of limiting and excess reactants. A limiting reactant is the one that gets used up in the reaction. It kind of stops the reaction because I don't have enough of that reactant. The excess reactant is something that I have plenty of. All right. Okay, so let's say I want to make some sandwiches. And so at home, I make a simple sandwich. I take 2 slices of bread, some mayonnaise, and 1 slice of turkey. I go to my fridge today, and here's what I have on hand. Now, with these available ingredients, based on the bread, with 2 slices per sandwich, I can only make 2 sandwiches. Based on the turkey, I could make 8 sandwiches. Based on the mayonnaise, I don't know, I could make 100 sandwiches. So, one of these is going to determine how many sandwiches I can make. That's the one that's going to limit the sandwiches, which is the bread. I can make a maximum of 2 sandwiches because I only have 4 slices of bread. We say this stops the reaction from happening and it limits the amount of product that I can make. So there's my limiting. As far as the excess reactant, well, I have extra turkey and extra mayonnaise. I have this one for you. I'd like you to figure out how many burgers you could make based on the available ingredients. Each burger takes 1 patty, 1 bun, a set of buns, 1 slice of cheese, and 2 tomatoes each. It's 2 tomatoes each. So figure out how many sandwiches or burgers you could make, and then how much of the extra ingredients would you have on hand? See what you got. So you should have said you can make a total of 3 burgers, and you would have an extra bun, 1 extra tomato, and 3 extra slices of cheese. We're going to do the same thing but with chemicals, and we'll do some calculations that are a little more difficult than that. Alright, so here are steps to solving limiting reactant problems. There's a lot, so get ready to write. 1. We're going to convert the mass of each given. So now we're going to end up having more than 1 given, like 2, usually, to the mass of the desired product. Now sometimes the product isn't even given to you. You just kind of have to figure out what it would be. So there could be just 1 product, or you could pick any product and say convert from the reactant to the product. Make sure that's the same product every time. Then you have to figure out which one is the limiting reactant. Well, the limiting reactant is going to be the one that results in the least amount of product. So, like my buns limited the amount, actually, like my sandwich bread limited the amount of sandwiches I could make. That kind of stops the reaction. Made the least amount of sandwiches, so that was the limiting reactant. The mass of the product, so my 2 sandwiches, was the mass that I got based on the limiting reactant. Then, the fun one, the mass of the excess reactant. So we'll have to calculate how much extra stuff we have. It's not as easy as saying, okay, we got 1 extra tomato and 3 extra slices of cheese. It's a little more difficult than that. What you have to do is do this. You have to first do a mass-to-mass conversion that will allow you to calculate the mass of the reactant that was used. Okay. Then all you have to do is take the mass of the excess reactant that you started with, subtract the mass that you calculated, and you'll have the leftover mass. Okay, so here's our problem. We have 4 things to solve. We have to figure out what's the limiting reactant, what's the excess reactant, what's the most amount of product that we can make based on those, and how much extra reactant is left over. So here it is. 10 grams of aluminum reacts with 35 grams of chlorine to produce aluminum chloride, and the balanced chemical equation is given. Okay. So let's just identify our givens. We have 10 grams of aluminum. Ooh, and we have 35 grams of chlorine. We have 2 givens here. What do we want to find? It says, it just says we're producing the aluminum chloride. Well, we're going to do a mass-to-mass problem. So our unknown is the number of grams. And since the product isn't told to me, I can assume that it's the only product that exists. It's aluminum chloride. Okay. And then we're going to figure out how many steps we have to do. Well, we're going to go from grams of aluminum to grams of aluminum chloride. Actually, what we're really doing is we're doing 2 different stoichiometry problems, 2 mass-to-mass problems, one with the first given and then one with the second given. And so we're going to go from gram to gram, a 3-step problem. And you should be pretty used to gram problems by now. You can almost do these within like a minute or 2. All right, so let's do it. We'll start with the first given, which is the 10 grams of aluminum, and we'll take that 2 grams of aluminum chloride. So 10 grams of aluminum. First step in a mass-to-mass problem is using the molar mass of the given. So I look at the aluminum, it's 26.98, and that's for every 1 mole of aluminum. And then the second step in a mass-to-mass problem is using the mole ratio. And so for the mole ratio, we have moles of the given on the bottom, so it cancels. And so according to the balanced equation, that would be 2 moles of aluminum. And then moles of the unknown on the top, which is 2 moles of aluminum chloride. Great. Next step, the third step in a mass-to-mass problem, is to use the molar mass. This time it's for the substance that we're trying to find, so that's aluminum chloride. So I'll have to say, okay, well, for every 1 mole of aluminum chloride, remember that's 1 in front. Notice there's a 1 here and a 1 there. The only time I have a number in front of mole that's not 1 is when you have the mole ratio. I have to add up aluminum and chlorine. So 1 aluminum and 3 chlorines ends up being 133.33 grams. If you don't believe me, go ahead and you calculate it. All right. So then cancel out all my units. Make sure that they cancel. Great. Everything looks good. Solve it, and I get 49.4 grams of aluminum chloride. And so what I can see here is just if I had 10 grams of aluminum, how much aluminum chloride could I make, given that I had an unlimited amount of chlorine. But I don't know how much I have, so we got to calculate that. So we'll start with the second given. So same thing, except for now we're going from chlorine to aluminum chloride. Another mass-to-mass problem. So I'm going to use GMMG, same pattern. 35 grams of chlorine, use the molar mass of chlorine. Now remember, you have to be careful. That chlorine's diatomic, so it's Cl2, which means it's 2 times 35.45 is equal to 1 mole. And then we need the mole ratio. So that would be 2 moles of aluminum chloride over 3 moles of chlorine. And last step would be to find the molar mass of aluminum chloride. Calculate that out. Well, we've already calculated, so that's 133.33. Cancel units. Great. Then my answer becomes 43.9. It's really close. Let's see. So let's compare those. Here we go. We got the first given gives me 49.4 grams of aluminum chloride. The second given gives me 43.9 grams of aluminum chloride. Which one is the actual amount of aluminum chloride that I can produce? Well, between these two numbers, it's always going to be the one that is the smallest. Okay? And the one that gives you that smallest number, that's going to be your limiting reactant. So my limiting reactant here, remember the reactant is has to be on the left-hand side of the arrow, so that's between aluminum and chlorine. So the limiting reactant is the one that gave me the least amount of product. So chlorine gave me the least amount of aluminum chloride. All right, let's see what else. That must be the excess reactant, because if I had enough chlorine, I could make more aluminum chloride based on the amount of aluminum that I have, but I can't. And then we also need to know, well, how much product is actually made. That's the least number between those two. So lots of information. Let's go ahead and write that in, actually write that down. That's the mass of product. And then we'll just compile that information into this. The limiting reactant was chlorine. Remember, chlorine is one of the reactants on the reactant side. I couldn't say it was aluminum chloride. You have to remember it's the thing that gave you the product, and that was chlorine. The excess reactant is the other, aluminum, and the mass of product was the least between those two answers. So it was 43.9 grams of aluminum chloride. Okay, so we're not quite done with this problem yet. What we still have left is calculating the mass of the excess reactant that remains. And so to do this, there's a little more stoichiometry and a little bit of subtraction. So here we go. To solve this, what you have to do is you have to start with the limiting reactant as you're given. So the mass of the limiting reactant was 35.0 grams of chlorine. Then you're going to take it to the grams of the excess reactant. That was aluminum. To do this, what we're doing is we're figuring out how much aluminum do you actually need. And then we're going to do a mass-to-mass problem, a gram-to-gram problem. So let's start. 35 grams of chlorine, use the molar mass of chlorine. That's equal to a mole. Then we have the second step, which is mole ratio. For every 3 moles of chlorine, we have 2 moles of aluminum according to the same balance equation we've been working with. And then, last step, to get from moles of aluminum to grams of aluminum, we need the molar mass of aluminum, which is 26.98 grams. Okay. Cancel out units, so just mass-to-mass problem going from the limiting reactant to the mass of the excess reactant. And what this gives me is this gives me how much aluminum was actually used in the reaction. So I used 8.88 grams of aluminum given the fact that I had 35 grams of chlorine. Okay, so we're almost done. So what this is just how much we use. So now we need to calculate how much is left over. Well, to start with, how much aluminum was I given? I was given 10 grams of aluminum. So I'll take the mass of aluminum that's given, I'll subtract the mass that actually got used, which is what I had to calculate, and that'll give me the mass of the excess reactant. So 10 grams of aluminum minus 8.8 grams of aluminum, the mass given minus the mass used, gives me 1.1 grams of aluminum in excess. Notice in terms of significant figures, this is subtraction, so I'm rounding to places. Okay, careful here. For places, the given mass, this one, has 1 place past the decimal. This one has 2 places past the decimal, so I had to round to 1 place past the decimal. All right, take some practice with these. I can show you one example, I can do some more in class. Some questions. Oh, actually, let's fill this out. It's not quite done yet. The mass of excess reactant that remains is 1.1 grams of aluminum. Next, I have some questions for you. And I want you to identify the limiting reactant in this problem. This problem's already been calculated. We have 25 grams of iron oxide and 25 grams of carbon monoxide. And we're trying to figure out how much iron is produced in this reaction. And so stoichiometry was done, and you have the 2 masses of iron that can be produced by those 2 reactants. Which one is the limiting reactant? Hopefully you got that right. It's the one that gave you the least amount of product was this. This is the maximum amount of product that it can make, and this is the reactant that gave you that maximum amount of product. Okay, another question. Here's a problem that's been done. It says, what's the maximum amount of product produced by the reaction of 5 grams of rubidium and 3.44 grams of magnesium chloride? It's not important about the reaction itself. The calculations are already done. All you have to do is look at the problem and look at the work that's been done and identify how much magnesium could have been made. Okay, what do you think? All right, we have 2 products of magnesium. This is the one that is the maximum amount because I'm limited by the rubidium. All right, one more. Okay, this one's a little fuzzy. Hopefully you can see. Here what's happened is iron trichloride has reacted with hydrogen sulfide. So they had 90 grams of iron trichloride and 52 grams of hydrogen sulfide. They reacted them together, and here's the amount of product that was produced. So 60.8 was produced by the iron trichloride, which made the iron trichloride the limiting reactant. Okay. To figure out how much excess reactant that remains, what was calculated was the 90 grams of iron trichloride all the way to 28.4 grams of H2S that reacted. Your job is to figure out how much excess hydrogen sulfide is there. Try it. Alright, so what you should have gotten is this. 52 grams of hydrogen sulfide, which is the amount that we started with, minus the 28.4 gives me 23.6 grams in excess. All right, we'll try some of these in class.